Hey, hello guys. Hope you guys are doing good. Let's solve today. Okay, there is some lead coins was there. Okay, let's solve today's lead code daily challenge. Today was June 29. Okay, yeah. Okay, today was the easiest one. Good, good, good. So, given the string of patterns and string word, okay, return the number of strings in the pattern that exist as a substring in the word. Okay, so we need to find okay number of strings. Interesting. So actually we can just do it in many ways. We can do this many ways actually. Like we can just directly use the count. So and then go for each pattern. Check if the word contains that pattern, or we can also do that. Index of this pattern was greater than 0, which is greater than -1, which means if it is not present, this index of will return -1. So we can just check if it is greater than 0, we can just take a count was 1 and take a count. So actually here I'm not going to sum it up, I'm going to just run it. I'm going to directly sum it up. So we don't end up with any compiler. Okay, yeah, this will get passed. I know, but actually we are not going to do in this way because yes, because like even the 10th or 12th standard students can able to do this. Like okay, now we can just go with the LPS array, like LPS array. So actually for this approach, the time complexity would be so the time complexity would be so actually for each pattern, let's say um, m be the pattern dot length, which means the number of words in patterns, and then n be the words length, the actual word length. So what would be the time complexity would be like? So actually for each word in m, so actually for each word in m, what we are doing for each word in m, so let's say for each word we are iterating. Okay, actually we are not even that's doing over here. So actually what the actual time complexity is, let's say if the word has a and then a b c and then some okay, and then our actual word would be a b c. Okay, let's say a b c a b c. Okay, I will take a perfect example, right? So if this is our actual word, and then if this is our actual pattern, you know what we're doing it. So if this index of will just compare, so for each index in the word it will just iterate. So for each index in the word, if it is matching, we will go. So actually for each word, in the pattern, we are just doing, at worst case for each word we are just iterating n times of n, which means for each, starting from each index we will just go. If we take this as example, it will just go, it will just start with the first index and then it will check okay, first are matching, and then I will just go. Let's say if this is example, okay, good, okay, here not good, then it will return -1. Then and then again we will start from the first index, good, bad, good, bad, good, bad, good, bad, and then we end. So actually in the worst case, what we are doing it over here. So for each word, so the actual time complexity would be, so for each word we are just doing this, so which means, so for each m we are ending up with n square. So for total number of words in pattern times of n square, right? So the actual time complexity would be, so here 100. At worst case, this is 10 power 6, which is high costly, right? So that's what we are just doing. That's why we have LPS. I think LPS that has, what was his name actually? LPS is a string matching pattern. String matching pattern. And then we also have the rolling hash. Rolling hash. If you are just new to DSA, just learn these two concepts, like LPS array and then rolling hash. So what we will get? So if by doing this operation, by doing these two methods, we can reduce this time complexity to, we can reduce at max we can just have like for each word for m times of n, so we can just reduce this n squared time complexity by doing this LPS operations, which means by doing this string matching operations. So yeah, what else? So actually the rolling hash I was very familiar with it. I will just try. I will try LPS. So actually if you try the LPS array, so here we need to, for each word in the pattern you need to form the LPS array. So that is even costlier than this. So I'll just go with the, I'll just go with the rolling hash. It's been a long while since I did the rolling hash. This WordPress. So with the actual string and then match, and then with the actual pattern as well. If you're doing roll hash, you need mod. Actually, we can just take any prime numbers. Only the prime numbers are allowed in the rolling hash. Yeah, exactly. If you're just hitting any mod, it will make sense. Okay, just take it to long as well. And this long. Um, Hash should be 0 initially, and then my base. Okay, just this all fine, right? Final, like private final. My base would be. I would just go with 51, some random prime numbers, and then yep, and then current hash was 0, and then we also need the factor, right? We can end up with 1. So yep, first take the first compute the value for the d, which means that the factors which we are going to subtract after each the subarray length. So pattern dot length. Okay, so it was not wrong. You need to take the d times of this and then do it mod. Okay, now we are in a good track. So now compute the hash for each words. Starts with I and then go until pattern dot length. Okay, so here we need to have hash 1 and then we can come to have hash 2. So yeah, so hash equal to like, so hash plus take the current character, take the mod of it. Oh no, this is the hash 1, right? So then do the same for hash 2 as well. And then then you need to move a bit, you need to write shift right. So hash 1 equal to like hash 1 times of base and the mod of mod. Actually we can just do it in a single line, but I prefer of doing it in this way. So we can just do it in a single line. Become more clumsier. Yeah. Okay, now what's that? Just do the same times of this. Close it and then mod also. Don't forget to open it. Yeah, here we go. At first check if both the hashes are equal, just simply say hey, the both hashes are equal, so the word was present. Okay, if not, just do like but just compute for each subarray of length. Okay, so then after, so actually, what if the pattern was the word was greater than this? So here we can check if my word dot length is smaller than my actual pattern dot length. So which means there is no way we can just form it right. So what if here's AB? What if the pattern was ABC? Definitely the word would be present in the whole string, right? So here we need to subtract it first. So hash 1 was, so the hash 1 minus what else? Okay, we need to subtract. Okay, we need to subtract this actual character. Okay, no, d times of this actual character. First subtract it, and then while if you are just doing any mod operation in that time, if you are just subtracting it for a burst case, just add mod to it so that it won't overflow. Just do the same. So this is not the I minus pattern dot. So is this right? Yeah. So and then repeat the same operations again, and then check if hash was there. Yes. Say hey, hash was not there, return false. We can just simply call this method by asking hey, if word is present, pass my actual word and then pattern. Yeah, here we go. Okay, that's some type of LENG. Okay, it's wrong. Interesting, right? This is even wrong. Because it's long. And then hash to what? Variable hash to cannot find symbol. Yep. So out of bounds exception. Good. Why pattern was made over here? We actually don't need to do it for hash 2, right? Because the hash 1 is common. Because yeah. Because the hash 2 is fixed, right? Yes, we go. Here we go, guys. And for just simplicity, I will just leave this and then test this. character was 4. Interesting. Our output was 0. I was thinking like why none of the cases was getting matched. Okay, you can check. So what else we are doing it over here, like for each hash we are just adding it, and then we are doing multiplication, we are multiplying it again. Okay, I think yeah. So I'll just check it for A, B, C, D as well. A, B, C, D as well. So actually here what is the important thing was you so actually here we are just what we are doing is um, first in rolling hash first we are just adding and then we are just adding and then we are just multiplying the base, right? Multiplying the base. So for if we are doing in this way we need to calculate the base for the whole string because this base has been applied to the whole pattern of length, right? Because let's say if it is a ABC, this we are just multiplying base 3 times, so we need to calculate this as 3 times. Then only when at the time of just subtracting the previous character, it will just match exactly the same. If you if we want to just do only for the first time, in that case, at first we need to multiply the base with the hash, and then we need to add. Yeah, but that's simple straightforward ways. I think this will work. Seems actually that is some problem. Okay, is this exist? No. Is this exist? Yeah, once, two, okay, three. Um, yes, definitely would be there. Four and then five. Good. So actually, what is we can just do is like, we can just try to print it out. Like, what are the characters which are matching? Because like rolling hash was not a stage for because if you are just doing a rolling hash, right, definitely we would end up with the calculating the hash might get sometimes the hash will be wrong. So E was there, yes was otherwise. Okay, this is not that. Okay, this guy is not being that. So I think our so actually the important thing in rolling hash we need to choose um, the unique mod and then the base, or else we just like end up with the same situation. We can just use another ways like is that getting solved or not. This doesn't helps. And then has to just add it and more and then again multiply it and then take more again. I'll just take something like 91. Okay, 91 is a prime number. Yeah. 91 doesn't go. Okay. 91 this is good. How come this is not even getting matched? I'll just try something like just take the exact example of this instead of this. I'll just remove all the words, extra words, and then I'll just remove only few of them at first. Seems like this is not a good match. I think that is because of this Z. If you remove Z and then if you add B, because Z was 25, right? I think yeah, my assumption was right. So So if you added a z over here, see, I'm having the same test case, but instead of b, I'm taking it z. It won't work. I know. I know it won't work. Yeah, I have said right. This z, because this z was 25, which is just computing the number as very much bigger. Okay. You're good at that. So, here. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we will add him, remove him, add him, remove him, add him, remove him. Seems okay to me, but okay, you can just try choosing a different mod numbers. What else we can just choose? Okay, can we try? Okay, can we try having the long numbers like 4, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, no, we need to just connect this to it. I think this will work. So, I've said right. So choosing the base and mod is very, very important while you are just working on encoding hash. Okay, this I P was the E was the what else am I missing? No, is it this guy? Yeah, this guy is missing. How come, man? This gives 17. Can't see. So what else we can try? We can try 257. So just choose 26 because we want 26 numbers, right? Yeah, work. This is why I don't like solving any of the questions in the rolling hash. I know definitely some more displays will fail again. I have said it right. Okay, wait, I need to wait. I've just asked ChatGPT and then come back with the best modern base for this one. I think ChatGPT just suggested me this and then try prospecting one. Good, none of them are matching. I have already said it right. If you just choose the worst more, then this machine won't work. just need to use the same with the 31 as base. Go by using 31 now the last. That is the best. How to find the best mode actually? Seems like this is fine. It asks me to work in this way. First do the multiplication multiply and then do mod and then it asks me to just do that and modify. Okay, as to okay, you're good enough. I think we're still okay, right? Wait a minute. No, it's easy. So the same, just do the same over here. Okay, just close this because taking model. None of this works. Here hash 2 was supposed to come. This is why I don't like this hash sometimes. First we are just a minute. What is the problem actually? The base was incorrect. How come none of my solutions are even working? Okay, seems fine. Okay, this is good. I think even this is also good to me. Last time first do the base and then add the new characters. That is good to me. Okay, there's no way just we need to print the hash. Okay, why the positive hash is going negative, which is hash 1, right? I still have confused, like after adding the mod, how come it can wait? Because the times of, let's take one more example. This, okay. Oh, the actual logic was correct, but seems like this is over. The numbers are overflowing. Okay, got it. So here, in the time of doing, we will take mod first, and then we need to add it, and then mod. Yeah. Yeah. Seems good. Yep. You guys might feel like, okay, I'll just. I think our first approach, that even that is exactly right. The way how we did. I was feeling like this is the place where we made a mistake. After doing, after multiplying, we need to take mod. Even this will work, right? I know. I have said right. This is a minor mistake. Okay, hope you guys stay consistent. Bye.